All right, so picking up where we left off on chapter 6, and we were on question 7. So here we want to convert 1.85 times 10 to the 22 atoms to moles. All right, so let's dissect the question a little bit. And when we're asked for atoms and moles, that tells us that we need to use Avogadro. Okay, Avogadro's number. Right, so that conversion is 6.02 times 10 to the 23rd atoms is a mole of atoms. Okay, just like, and I've said this before, just like a dozen donuts is 12 donuts. This is a mole of atoms is 6.02 times 10 to the 23rd atoms. Okay, so let's approach this like any other conversion problem. And again, I encourage you to pause this video, work it out yourself, and then see if you get the same answer. That's where you get the practice. All right, so assuming you've done that, we're going to start with our given information. And I'm going to write a conversion that has number of atoms on the bottom and moles on top. Okay, that way the atoms cancel out, and I'm left with moles of atoms. And so we should come out to be 0.0307 atoms. Right, now, a quick note on sig figs. So this thing, this Avogadro's number, this is a definition. Right, and definitions are assumed to be exact. Right, so we don't have to worry about that for sig figs. So where my sig figs comes in is the 1.85. So 3 sig figs in my initial information and 3 sig figs in my answer. All right, so 7b. How many molecules are in 4.32 moles? Again, we're dealing with a counting thing, so how many molecules and moles, right? Those things go together, and we know we need to use Avogadro. Right? So we start with 4.32 moles, and we're going to use the conversion that has moles on the bottom because I want to cancel out the moles. So Avogadro goes on the top. So that many molecules per mole of molecules. Okay, so my moles will cancel out, and it just leaves me with an answer in molecules. So we should come out to be 2.60 times 10 to the 24 molecules. And I'm going to abbreviate that because I'm running out of room there. All right, so checking our work here, we got 0.0307 moles for our answer to 7a, and 7b, 2.6 times 10 to the 24 molecules. All right, so number 8. So what is the mass in grams of that many uranium atoms? 5.0 times 10 to the 24. So sort of dissecting the question again, grams, that's going to lead us to the idea of molar mass, because our units of molar mass are grams and moles. But atoms, that comes from Avogadro. Avogadro. I have to sound that out every time. Okay, so we're going to have a two-step problem here. Right? So our molar mass for uranium is 238.03 grams per mole. And I take that right off of the periodic table. Okay, so first I need to convert to moles before I can use molar mass. Okay, so if I'm starting with atoms, my gateway to molar mass is through moles. So I'm going to use Avogadro to get to moles and then use molar mass. Okay, so 5.0 times 10 to the 24 atoms of uranium. And so my first conversion is to convert to moles. So I'm going to put atoms on the bottom. And moles on top. Okay, so atoms of uranium will cancel out. So if I stopped here, I would have an answer that was moles of uranium. So now I'm going to use molar mass to get to grams of uranium. Okay, so right now I have moles, so I want to put moles on the bottom of my next conversion. All right, so moles of uranium will cancel out, leaving me with an answer in grams of uranium. And so we get 1976 grams of uranium. Now here we have to pay attention to our sig figs. Right? So the Avogadro's number part, our first step, that's a definition, so we don't have to worry about that. Our second step with the molar mass, that number counts for sig figs. Right? So that number has 5 sig figs in it. But our initial number only has 2. So 5.0 over here on the left only has 2 sig figs. Right? So we're doing multiplication division. So we have to care about sig figs. So I'm going to stop that answer at the second significant digit. So to report this answer correctly for sig figs, I'm going to say 2.0 times 10 to the 3 grams of uranium, because that 2.0 gives me the correct number of significant digits. All right, let's take a look at our next problem. Question 9, converting 5.2 grams of helium to moles. So noticing what we have in the problem, we have grams and we have moles. That tells us molar mass. Right? So our molar mass of helium is 4.00 grams per mole. And I take that right off the periodic table. Okay, so nothing fancy with this particular problem. So 5.20 grams of helium. And I'm going to write my conversion factors so that grams are on the bottom, because I want grams to go away. So my grams will cancel, leaving me with moles of helium. So we end up with 1.30 moles of helium. Okay, remembering that molar mass, we do have to care about sig figs with molar mass. Okay, that's a measured quantity. Right, so 3 sig figs in our initial amount, 3 sig figs in our molar mass, so our final answer will have 3 sig figs. Oh, hold on a minute. Turns out that I put the wrong answer there. Hold on a minute. Grams of helium to moles. Oh, that's right. Sorry about that. So this should this should contain the correct answer. Sometimes when I transfer things to my pad to do these videos, things don't transfer correctly. So they're still on question 9. So let's look at question 10. So what is the mass of 1.03 moles of sodium bromide? So if I have mass in grams and I have moles, that tells me that I'm going to use molar mass, because my units of molar mass are grams and moles. All right, so I need the formula mass of sodium bromide. So I have one sodium, so 1 times 22.99 grams per mole, and I have 1 bromine, so 1 times 79.90 grams per mole. So I can just add those directly because I'm not multiplying. We come out to be 102.89 grams per mole. Okay, for sodium bromide. So I'm going to start with my moles. And I'm going to put moles on the bottom of my conversion. So 102.89 goes with grams. For every mole of sodium bromide. And again, I want to encourage you, when you say these things, say it out loud to yourself. 102.89 grams. That number goes with the grams, okay, per mole. Our moles of NABR cancel out. And so we end up with an answer to the correct sig figs of 106 grams of NABR, sodium bromide. And again, things didn't transfer quite correctly with my pad. But we're going to go ahead and stop on this video. We'll come back on the next video and continue on for the next 4 questions.